Hello everyone, this is Anand Goud, Assistant Professor, Civil Engineering Department from Institute of Aeronautical Engineering. So today we are discussing about the topic classification of aggregates and characteristics of good sand or fine aggregates. So the outcome of this lecture is, after completion of this topic, you can summarize the basic physical and chemical properties of construction materials for determining the quality of concrete. Coming to the contents, we are discussing about the introduction part of aggregates and classification based upon the geological origin and source, and based upon the size, and classification based upon the size, and the characteristics of good sand. So coming to the introduction part here, so aggregates are inert materials, right? Okay, we are assuming that aggregates are inert material. That means it should not react. It will not react with any other material which is there in the concrete, like cement and water. Okay, so that is our assumption. So these aggregates will be acting as a filler material for mortar and concrete. That means most of the space will be occupied with the aggregates, and aggregates gives body to the concrete. Okay, they will be acting as a skeleton to the aggregate, and most of the shape or body, whatever the body we are getting, that is because of aggregates. Okay, and it reduces the shrinkage. Okay, if you use aggregates in the concrete, they are going to reduce the shrinkage property, because instead of cement we are going to use aggregates as a filler material, right? So if you reduce the cement content, automatically we can reduce the shrinkage, because the cement property of, the natural property of the cement is it is going to shrink whenever it reacts with the water, and it is going to form a body, and whenever the temperature changes nearby such materials, then it is going to evaporate and it is going to shrink, right? And you will get the cracks on the cement member. Okay, so that is why if you replace that cement with the aggregates, okay, most of the space, if you fill with the aggregates, then we can reduce the shrinkage. And aggregates occupies 70 to 80% of total volume of concrete. Okay, almost 70 to 80% of volume will be occupied with the aggregates, and remaining 30% will be like cement and fine aggregates, cement and water. Okay. And next, hence the impact on properties of concrete is considered. So due to this reason, because most of the space will be occupied with the aggregates, right? So that is why the study of this particular aggregates is very important, and the impact of aggregates on the properties of the concrete will be more compared to other materials. Okay, that is the reason we are going to study about the properties of aggregates separately. And selection of aggregates is also very important. Okay, so in this picture you can see we have different types of aggregates, like this is a fine aggregate, that is natural sand, and this is the coarse aggregate, and this is the manufactured sand, okay, which is obtained from the crushing of stones. And one more reason for studying about the properties of aggregates is, see, in concrete preparation we are going to use different materials such as cement, aggregate, and water, right? So these are the common materials for preparing the basic concrete or conventional concrete, right? So if you take the cement, this is factor image. That means we know the properties. We are manufacturing the cement as per our requirement, and we are checking the chemical composition everywhere, right? In every activity while manufacturing the cement, we are going to check the chemical composition, and we know the properties. Okay, that is fine. Okay, that means in a controlled environment we are going to prepare the cement. And then coming to the aggregates here, this is natural, okay, and water is also natural. That means these are naturally available materials. Okay, aggregates and water. So depending upon the environment condition, the properties of aggregates will change. Suppose if you collect the aggregates from one source, one area, the properties will be different. And if you collect the aggregates from another area, okay, on the surface of the earth, so that will have different properties. So depending upon the environment conditions surrounded by the particular aggregates, the properties of aggregates will change, right? So that is the reason, okay, we are going to collect all the aggregates from different sources. From one source we cannot get total aggregates, and the properties will be different, right? So this is the reason. Okay, we don't know the property of aggregates. Okay, we are not manufacturing the aggregates in a controlled environment. So that is the reason we have to study about the properties of aggregates. Coming to the phases of concrete here, see, we are dividing the concrete phases into two phases, that is paste phase and aggregate phase, as we have discussed in the previous lecture. We have already studied about the paste phase. Okay, it is already completed in the previous lectures. Okay, like paste phase is nothing but we have studied about the cement. Okay, and its behavior, properties, and classification. Okay, that is nothing but paste phase. And next one is aggregate phase. So if you know about these two phases different, I mean separately, then you can prepare the concrete with good qualities. Okay, so now we will study about the aggregates. So the study of aggregates can be done by the following test methods. The first one is based upon the classification. Okay, that is one of the um, property we are going to study in the study of aggregates. And then source, okay, from where we are going to collect, and size of the aggregates, and shape of the aggregates, okay, and strength of the aggregates, bone density, and moisture content, and cleanliness of the aggregates, and soundness of the aggregates, durability of the aggregates, and sieve analysis of the aggregates, and grading. Okay, so if you study about all these properties separately, then you can get some idea about the properties of aggregates. Okay, so now we will discuss about the classification of aggregates. So aggregates normally classified into three types based upon their weight. Okay, that is normal weight aggregates, and lightweight aggregates, and heavy weight aggregates. Okay, this is the basic classification based upon the weight. Okay, under normal weight aggregates, again based upon the geological origin, whether they are formed naturally or artificial, they have divided into two types again. The first one is natural aggregates, and second one is artificial aggregates. Okay, so now normal weight aggregates. Okay, coming to the normal weight aggregates here based upon the geological origin and source. So natural aggregates. Okay, under this normal weight aggregates, we are going to study about the natural aggregates. So these natural aggregates are obtained from crushing the quarries of igneous rocks. Okay, so by crushing, we are going to get these particular natural aggregates. Crushing of igneous rocks, okay, sedimentary rocks, and metamorphic rocks. Okay, from these three rocks, okay, after blasting or crushing these three rocks, we are going to get the natural aggregates. Okay, and these are called as a crushed stone aggregates. Okay, and the examples for natural aggregates are gravel, okay, and sand formed by natural agencies. Okay, due to the wind action, due to the weathering agents. Okay, that sand will be called as a natural aggregates, and gravel also. And first one is crushed stone. Okay, so for examples of natural aggregates are like crushed rock, okay, granite, quartzite, basalt, and sandstone, sand, and gravel. Okay, these are the examples for natural aggregates. Next one, artificial aggregates. So here artificial aggregates are nothing but we are going to manufacture these aggregates, okay, by using different materials. Okay, in that first one is broken brick, or it is also called as a brick bats. Okay, broken brick or brick bats. Okay, and these are nothing but small pieces of bricks. Okay, you can see in this picture. Okay, so while construction or else while placing, while transporting, some bricks may be broken into parts, okay, pieces. So those pieces are also used in the construction, which are suitable for mass concrete. That means as a filler material, like foundations or bases, okay, for filling the foundations or for filling the base courses, okay, while casting the slabs. Okay, here you can see this picture. Okay, so for construction this foundations and bases, we are going to use these type of brick bats or else broken brick pieces. Okay, and these are suitable for mass concreting. Okay, whenever you are going to cast huge components with concrete there as a filler material, we can use these brick bats. Okay, and these are not used for RC works. Okay, for reinforced cement concrete works, we are not going to use this type of brick bat because they are not going to give good results in terms of strength and in terms of placing that particular pieces. Okay, second one, blast furnace slab. Okay, so these are obtained by slow cooling of slag followed by crushing. Okay, these particular blast furnace slag aggregates will be obtained by slow cooling of slag. Okay, blast furnace slag. Okay, while manufacturing the iron, okay, from the iron ores, okay, we are going to get the waste material. Okay, that particular slag is called, and waste material is called as a blast furnace slag, and these particular slag is also used as a aggregates. Okay, in this picture you can see this is the aggregate we are going to prepare, okay, in the construction, and these aggregates will have good fire resisting properties, okay, because they are already subjected to very high temperature and it is very compact, okay, and causes corrosion of reinforcement due to sulfur content of slag. So in this particular slag we will be having the sulfur content which is going to affect the corrosion, okay, which is going to affect the reinforcement, like with corrosion, okay. So wherever you have RC structures, there we have to limit the application of this slag aggregates. Okay, and next one, sintered fly ash aggregates. Okay, sintered fly ash aggregates are nothing but this fly ash will be subjected to heat. Okay, whatever the fly ash we have prepared, that will be again subjected to very high amount of heat, and that will be, that particular material will be formed as a small round particles like this. Okay, and this is called as a sintered fly ash aggregates. Okay, which we are going to use in the construct concrete. Okay, and next one, bloated aggregates or else expanded clay aggregates. Okay, expanded clay or shale. Okay, so these aggregates will be obtained by subjecting the clay to a temperature of 1200 degrees Celsius. Okay, so the clay is subjected to 1200 degrees Celsius temperature. Okay, okay, and then we are going to get these round particles, and this will be used as a aggregates in the concrete, and these are called as a bloated aggregates. Okay, bloated clay aggregates are bloated aggregates, and these aggregates will have very lightweight, okay, and density is also very less. Next classification based upon the size. Okay, so based upon the size also we have divided the aggregates into different types. So the maximum size of the aggregates in the for concrete is 80 mm. Okay, so the 80 mm up to 80 mm size aggregates we are going to use in the concrete. So usage of maximum size aggregates will be resulting in, okay, so if you use maximum size aggregates or bigger size aggregates in the concrete preparation, then what is the result? Okay, see, the first one is reduction of cement content. Okay, we are going to reduce the cement content by adding the aggregates. Okay, and next one, reduction of water content. Okay, so if you reduce the cement content, automatically the water content requirement is also less. Okay, and next one, reduction of drying shrinkage. Okay, these three are interlinked. Okay, if the cement content is less, automatically we can reduce the water content, and then drying shrinkage also reduces, right? So most of the shrinkage we are going to get in the concrete, that is because of cement. So if you reduce the cement content, automatically you can reduce the shrinkage. Okay, that is the those are the results if you use maximum size aggregates in the concrete. And next one, maximum size aggregates usage is limited by following conditions. So here we are going to limit the size of the aggregates based upon the following conditions, that is thickness of section and spacing of reinforcement, okay, clear cover, and mixing, handling, and placing techniques. So thickness of the section means depending upon the size of the component we are going to cast, based upon the thickness we are going to add the aggregate size. Suppose if the thickness of the aggregate, thickness of the member is only 10 mm, 10 centimeters, or it's 10 mm, so or else 20 mm. Okay, 20 mm is the thickness of this particular member. So here you have to use less than 20 mm size aggregates. Then only you can cast or you can prepare the concrete and you can place it properly. Suppose if you use more than 20 mm size aggregates or else 20 mm aggregate also, it is going to block this total area. Okay, there is no scope for placing the concrete material. Okay, only aggregates are going to occupy, and that is not ideal. Okay, and next one, spacing of reinforcement. Okay, so now if you see this picture, so depending upon the spacing between these two reinforcement bars, okay, we are going to use the aggregates. Okay, so if the aggregate, if the spacing is less, then according to that size we have to use the aggregate size, maximum size aggregate. Okay, and next one, clear cover. So This is the clear cover seam. This is the reinforcement we are going to place in the member, and this is the boundary where the member will be closed. Okay, so now based upon this gap, okay, whatever the clear cover we are placing, based upon that clear cover also, we are going to limit the aggregate size. Okay, and mixing, handling, and placing techniques. Okay, so depending upon the mixing techniques, okay, we have, okay, if you are going to do hand mixing, then if you take bigger size aggregates, then it will be somewhat hard for mixing the material. Okay, so that is why based upon the techniques we have for placing, mixing, and handling, then we are going to use the different size aggregates, and we have to limit the maximum size aggregates to smaller size aggregates. Okay, now coming to the classification here, we are dividing the aggregates into two types based upon the size. The first one is coarse aggregate. Okay, so here this coarse aggregate will have the size more than 4.75 mm. Okay, if the aggregate size is more than 4.75 mm, then that is called as a coarse aggregate. Okay, and coming to the maximum size of coarse aggregate is 80 mm, right? So for reinforced sections, the maximum size is equals to 5 mm less than clear cover. Okay, based upon the clear cover, we are going to take 5 mm less value. Okay, while using the coarse aggregate in the preparation of concrete. And next, coming to the fine aggregate, the size is less than or equal to 4.75. Okay, if the size of the aggregate is less than or equal to 4.75, that is called as a fine aggregate, right? And the minimum size of fine aggregate is 0.06 mm. Okay, 0.06 mm is the minimum size of aggregates. And next one, natural or artificial. Okay, in this we have different types of aggregates again, natural or artificial, and again in the fine aggregate, fine aggregate and medium coarse and coarse aggregate. Okay, fine sand, medium sand, and coarse sand. These are the different types of fine aggregate based upon size. Okay, so coming to the detailed explanation about the fine aggregate, see aggregates whose particle size or else whose particles passing through the 4.75 mm sieve that are termed as fine aggregate, right? Okay, so most commonly used fine aggregate are sand. Okay, that is pit sand or else quarry sand or else river sand or sea sand, and crushed stone in powdered form. Okay, these are the fine aggregate we are going to use. Okay, next, fine aggregate here based upon the size of the fine aggregate again in this particular material, we have divided again this material into different size, different sands. The first one is coarse sand. This will have the size from 0.5 to 2 mm. Okay, this is called as a coarse sand. And if the size is 0.25 mm to 0.5 mm, that is termed as medium sand. The next one, from 0.06 mm to 0.25 mm, it is termed as fine sand. Okay, and next one, silt. Okay, from 0.02 mm to 0.06 mm. Okay, that is called as a silt. The next one, if the particle size is less than 0.002, that is called as a, suppose if the particle size is less than 0.002, then that is called as a clay. Coming to the characteristics of good sand. So if the fine aggregate is called as a good sand, then that particular sand or fine aggregate should have the following properties. First one, should consist of coarse, sharp, angular, hard grains. Okay, so whatever the sample you are using as a fine aggregate in the concrete preparation, it should have coarse, coarse sand and sharp, angular, and hard grains. Okay, the strength should be more. The strength should be more, and it should have sharp, angular edges. Okay, and grains must be clean and free from clay. Okay, grains must be free, I mean clean and free from clay. Okay, it should not contain any clay particles on the surface of the sand. Next one, free from organic materials. Okay, so it should not contain any organic material in the sample. And next one, free from chemicals. Okay, it should not contain any chemicals. Okay, and strong and durable. Okay, the strength of the aggregate, fine aggregate should be very high and it should be durable. And grains should be well graded for good workability and strength. Okay, the grading of the aggregate should be very well. Okay, it should have very less voids. Okay, it should have very less voids. Okay, and the workability, I mean, this gradation will be useful for good workability. Next one, fineness modulus should be 2 to 3. Okay, the fineness modulus value 3. Next one, free from dust. Okay, it should not contain dust particle. Okay, fineness modulus should be 2 to 3, and it should not contain any dust particle. Okay, and uniform color. Okay, the fine aggregate should have uniform color. Okay, so these are the different characteristics if you want to call it as a good sand. Okay, these are the characteristics of good sand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.